Hello and welcome to this R tutorial. Previously we implemented the kernel SVM in Python and now we're going to do it on R. So for those of you who haven't checked the Python tutorials on kernel SVM, I can't wait to show you the results. It's going to be something. You'll definitely see how the kernel SVM classifier can be a powerful classifier, especially in our situation where the dataset is not linearly separable. Here you're going to see how it can manage to overcome this non-linear separability and classify most of our users of the social network correctly. So let's make this kernel SVM classifier right now and quickly look at the results. So as usual, we're going to start by setting our working directory. So right now I'm on my desktop. I'm going to my machine learning AZ folder, part 3 classification, section kernel SVM, and here we are. Make sure that you have the social network add CSV file in your folder, and if that's the case, you're ready to click on this more button here to set your folder as working directory. Here it is, all good. And now let's start making our model. So we made an awesome classification template in the logistic regression section, so we're going to use it. So here we're going to take everything from here to the end, copy this, and simply paste it in the kernel SVM R file. And now what we only need to do is to create our classifier here, because the template is made in such a way to make your machine learning experience as efficient as possible. So we're not going to create it now. First, we're going to, select all the data preprocessing first step to preprocess the data. So we're going to press Command and Control plus Enter to execute, and all good. As you can see, the code executed properly. Now we can have a quick look at the data set, the training set and the test set. So we can see that we have 400 observations in the data set, 300 that were selected to go to the training set, and 100 selected to go to the test set. That's because of our 0.75 split ratio here. And quick reminder, this data set is about a social network that contains information about users in a social network. So we have their age, the estimated salary, and the last column tells if yes or no the users bought a product of a business client of this social network, which is a car company. So this car company put ads on the social network, and the social network gathered those informations to see the user's reaction. And so 0 means here that the user didn't buy the SUV, and 1 here means that the user bought the SUV. And our goal now is to make a classifier that classifies those users into two categories: the category of users that didn't buy the SUV and the category of users that bought the SUV. So let's do this. Let's do it with kernel SVM. And so right now we need to create our classifier. And as usual, it's going to be very intuitive and simple. We're going to use the best library for this. And besides, if you watched the SVM tutorials, you're going to see that we're using the same library and the same function. We will just need to change some parameters. So let's do this. For those of you who didn't follow the SVM tutorials, you need to install a package. So to do this, you type this command, install.packages, and in parentheses and quotes, E1071. So that's the most popular package for SVMs. Another very popular package is kernel. You can play around and check it out. It's actually quite simple. It's kind of the same function, only with slightly different parameters to input, but it's also a great package for SVMs. But here we're going to use E1071, which is one of the most popular packages. And so that's for you guys who, if you go to your packages list here, and if you go to E1071, you can see that I have this package installed on my packages. It might not be the case for you, so that's why I'm adding this line here in case you don't have the package installed on your packages in R. So I won't do it right now. You just need to select this line and execute, and it will install the package very quickly. So I'm just going to put that in comment. I just pressed Command Shift plus C. And now we need to do another important thing about this library, is to, type this common library and then in parentheses the name, not in quote, of the library, E1071, okay? And we need to add this line. It's very important in case we have some automated scripts that, make some kernel SVM models to dataset. So imagine you have a workflow and you want to include a kernel SVM model in this workflow. Well, you will need some automated scripts. So it's important to add this line because this will automatically select your library, because as you can see here, it's not selected. That means it's not imported in some way. So you need this line that will automatically select this package. Okay? And now we're ready to create our classifier. So it's going to be the same as for SVM, which is actually an SVM with a linear kernel. Here we're not going to use a linear kernel. We're going to use something else, which will be the Gaussian kernel. So let's do this. We're going to call our classifier as usual classifier, and then equal, and then here we're going to use the SVM function of the E1071 library. And now we need to import the parameter. So as usual, let's have a look. Here it is. And now you need to click on this. And here we are in the R documentation for SVM E1071. Okay, so let's have a look at the arguments. The first argument is formula. So as for SVM, it's going to be purchased tilde and then a point. And the point represents all the independent variables. So we know this. Then data. Okay, so yes, you need to specify the data because you want to specify the data set on which you want to train your kernel SVM model. So we need to specify data equals training set because we are training a model on the training set. Then X, Y, and scale are not important here. What's really important are the type and the kernel. So the type is whether you want to make a regression model, that is SVM for regression, that is SVR that we saw in the regression part, or SVM for classification, which is the common way of saying SVM. So here we will need to specify the C classification type, which is the default type for classification for SVM. Remember in the SVR we chose EPS regression, that was the default type for regression for SVM. But here we are in classification, so we will choose this C classification type. And then the most important is the kernel. Here we jumped to a higher level. We are making a more sophisticated SVM than the SVM we did in the previous section, which was a linear kernel SVM. But now we want to go pro and we are choosing a Gaussian SVM, which you will see make a terrific job at classifying your users in the social network. Because remember, the kernel SVM was linear, which made our SVM model a linear classifier, and therefore the separating the two classes of users was a straight line here, and therefore couldn't catch the users here. That made our dataset non-linearly separable. So here we're going to choose the Gaussian kernel, which is going to be the radial basis kernel. Actually, we're not going to write radial basis, we're just going to write radial. That's how it works. But the Gaussian kernel is radial. Actually, you can see the formula here. Kirill gave you the formula of the Gaussian kernel, and here it is. Okay, so now let's jump back to our code and let's implement this. Okay, so remember the first argument was formula, and then here we have to first take the dependent variable, which is purchased. You know, if you go back to our data set, this is the dependent variable and this is purchased. Then tilde, which is alt n, and then a dot to take all the independent variables of our training set. That is, we're taking age and estimated salary. All right, then comma to go to the next argument, enter, and then the second argument. So the second argument, remember, it was data equals the training set. Okay, and then the next parameter, what was it? It was type. Type equals C classification. Actually, we don't really need to input the type here because it's the default type. But let's specify this to, make the distinction between SVM for regression, SVR, and SVM for classification, kernel SVM here. And then of course we will add the essential parameter for this section, kernel SVM, which is of course kernel, and that's where we pick our more sophisticated kernel, which is the Gaussian kernel called here radial. All right, and now our classifier is ready. So let's immediately select this. And perfect, our classifier is now built. So now let's use it to predict the test set results. So we're going to select this line simply and press Command and Control plus Enter to execute. And here is our ypred. Let's have a look. Ypred, we type ypred here in the console, press Enter. And here we have all the predictions for the test set. So there are 100 predictions. So let's have a look at the first one. So we need to compare this ypred, which is the vector of predictions, with the true results of the observations, the true results whether they bought yes or no the SUV. And for this we need to go to the test set here to check it out. So let's see. The 1, 2, 3, 4, and 5 users didn't buy the SUV in reality, and our predictor predicted that these same 5 users didn't buy the SUV. So that's some correct predictions. It's a very good start. Then if we look at the next observation, we have one here, one here, one here, one here. So that makes the 8 first predictions correct predictions. And here we have our first mistake, our first incorrect predictions, because for the user number 22, our classifier predicts that this user wouldn't buy the SUV, and in reality it did. If we look at the number 22, we can see that we have a 1 here, which means that this user bought the SUV. Okay, so, but the best way to look at these predictions is to use the confusion matrix. So let's do this. The section is here already. We don't have to change anything. The template is there to ease our work. So let's select this line, press Command and Control plus Enter to execute. And here we have our matrix. So we're going to look at it in the console. So CM here, Enter, and here is the matrix. Okay, so what do we have here? We have 58 plus 32 equals 90 correct predictions, and 4 plus 6 equals 10 incorrect predictions. So that's not too bad. But now the most exciting part is coming, because we're going to be visualizing the training set results. And actually right now we don't have to change anything except maybe the title here, classifier, and then here you need to specify kernel SVM, as well as here in the test set. So here kernel SVM as well. All right, now we can get some coffee and just execute this and watch the results. So we're going to do this. We're going to first look at the results here and press Command and Control plus Enter to execute. And wow, these are the beautiful results of kernel SVM. We can see how it's making this curve here to classify well most of the users in the social network. Here, since we have a 2-dimensional space here for the dataset, that means that the dataset was mapped to a 3D dimensional space. And then on this dimensional space, it managed to make the data linearly separable so that it can find a linear hyperplane that separates in a much better way the two classes, and then it projected back to this 2-dimensional space to finally obtain this curve here that separates in a much better way the two classes than a linear classifier would do with a straight line here, as we saw for logistic regression or SVM with the linear kernel. So that's what happened. That's what happened behind the scenes. The kernel SVM did an amazing job, so we can say congrats. Okay, so for those of you who are seeing this for the first time, I'll just quickly remind what it is. The points here are the true observations, the true results. So the red points are the users who didn't buy the SUV in reality, and the green points are the users who bought the SUV. And then the regions that we see here are the prediction regions. So the red region is the region where our model predicts that the user doesn't buy the SUV, and the green region is the one where our model predicts that the user buys the SUV. So for example, that means that for this particular user, red point, which is in the green region, that makes an incorrect prediction because the truth is the user didn't buy the SUV. But since this user is in the green region, that means that the model predicted that this user bought the SUV, even if that's not what happened in real life. So that's what the graph is about. And here is the nonlinear separator of the kernel SVM algorithm. And thanks to this nonlinear separator, our kernel SVM could classify correctly those users here, which wasn't the case for the linear separators, because since we had the straight lines, it couldn't catch these users in the right category, that is the green category, because those users actually bought the SUV in real life, so they should be in the green region. And this wasn't the case for the linear separator, and now it's the case for the kernel SVM separator, because it's a nonlinear classifier. Perfect, now let's have a look at the test set results to see how our model behaves on new observations, to see if it can still classify and predict the results of new observations. So we're going to do this. We only have to select this, press Command and Control plus Enter to execute. And here are the test set results. Okay, so that looks great as well. First, an important thing to understand is that the regions that we see here are the same regions as we saw in the dataset. If you go back to the training set and then go back to the test set, you can see that the regions here don't change. Only the observation points change because, of course, these are new observation points. And so here we can see that the kernel SVM did an amazing job at classifying new observations, because all these test set observations here are the users who didn't buy the SUV because the points are red, and they are in the red region. That is the region where our classifier predicts that the users don't buy the SUV. So that's correct predictions. Same for these guys here, all the green points that fall in the green region. And of course we have those incorrect predictions, which are, for example, this green user here who is in the red region, as well as those two green here, so that's 3. Then we have the red users, this one, so 4, 5, 6, 7, 8, 9, and actually 10. We can see that there is a little green point here hiding behind the red point. Okay, yeah, so that's definitely a very good job. You will see how the next classifiers will make a different style of classification, of separation. You will see that it won't be a curve, it will be something else, and I will let you find out about the surprise. But definitely the kernel SVM is a great classifier when your data is not linearly separable, and we can see how it definitely improved the results of the linear classifiers that we saw with the logistic regression and SVM. Alright, so thank you for watching this tutorial about kernel SVM. I hope you enjoyed it. There will be a few more surprises with the next classifiers, as I told you. So you're gonna see the results, it's gonna be pretty fun. And so I look forward to seeing you in the next sections.